Good morning everybody. I am Rajeshwari, working as a lecturer in Karaikal Polytechnic College, Karaikal. During the lab activity in the AV section of this online course, I included the NPTEL video for the topic semiconductors. For a student to understand this video, he has to be crystal clear about the basic semiconductors. For this purpose, I have prepared this PowerPoint presentation. Now let us go for the presentation. Semiconductors are key elements in today's electronic scene. Whatever may be the electronic device, all have semiconductor. First of all, we should know what is semiconductor, insulator, and conductor. Conductors and non-conductors. Conductors means conduct electricity freely. Electrons will move freely around the lattice. Non-conductor means acts as insulators, preventing the flow of electric current. Electrons will not move freely around the lattice. Semiconductors, neither a true conductor nor an insulator. Semiconductor examples are germanium, silicon, gallium, and arsenide. You can see the atomic structure of a pure silicon. Also, the pure silicon atomic number is 14. It is arranged in its orbit. Also, the silicon crystal lattice shows the arrangement of silicon atoms. Semiconductors classification. Intrinsic material, pure form of any material, possess very low conductivity level. Eccentric material, small amount of added impurity to the intrinsic material. What is impurity? Semiconductor changes significantly by adding a very small amount of impurity. Materials having surplus of electrons, we call it as N-type semiconductors. Example, phosphorus and arsenic impurity. Materials has lack of electrons, we call it as P-type material. Example for P-type impurity are boron and aluminium. Semiconductors, holes and electrons. In a semiconductor, by means of adding impurities, electrons move freely around the lattice. When an electron moves to fill a hole, it leaves a hole. Electrons or holes can carry a charge, so they are called as charge carriers. Electron charge carrier for N-type semiconductor and hole charge carrier for P-type semiconductor. Semiconductor p-n junction diode theory. Fundamental structure in semiconductor technology is p-n junction. It is a basic for all electronic devices. P-n junction is formed by one end p-type with p-type material and other end with n-type material. N-side type will have excess of electrons and p-side type will have excess of holes. When two areas of p and n meets, electron fills the holes. Therefore, no free holes or electrons. We can say that both the charges are depleted. This depleted area is called as depletion region. Semiconductor biasing. The first diagram shows the p-n junction with no bias applied. The second one shows the p-n junction with applied forward bias. And the third one shows the p-n junction with reverse bias voltage. This shows the p-n junction characteristics. Voltage versus current characteristics of p-n junction diode with forward bias. It can be seen that a very little current or no current flows until a certain voltage. This shows that the applied voltage, bias voltage, is required to make the charge carriers to cross the depletion layer. This voltage varies from semiconductor to semiconductor. For germanium, it is 0.2 or 0.3 volts, and for silicon, it is about 0.6 volts. So, I can summarize the content as the basic semiconductor diode is having only limited applications, but by doing some specialization we can make the diode for any different particular applications. I could say LED and photodiodes are the two well-known examples. p-n junction is also basics of bipolar transistor and junction FET. As a result, many billions of semiconductor diodes are manufactured each year. Thank you for listening.